Okay, this lesson is on what I call famous limits, and we're going to talk about trig limits. And so there are four famous limits that I want you to know, and it's these four right here. This first one, we have the limit as x approaches a of c equals c. And here a is standing for an x value, a number. C is standing for a plane number. And so if you think about what it is for a plane number to be like f of x, so if you had f of x equals 2, that means you have a horizontal line. And if you think about a horizontal line, all of the y values on that line would be the same because, like, again, if it was y equals 2 or f of x equals 2, you might have the point 0, 2 and the point 3, 2 and so on, but all the y values on that line are the same. And so since the answer to a limit is a y value and all the y values are the same, it would always be whatever that y value is. Okay, and we'll do some examples in just a moment. There's three others that you need to memorize. Probably the most used one is this one right here, and you need to check, first of all, it has to be the limit as x approaches 0, and either it has to be sine x over x or x over sine x, and if that's the case, that limit is 1. It's something you just memorize. It can also be if these things match. So if I had 5x here and 5x here, the limit would still be 1, and I'll show you some problems about how we're going to use that to our advantage to help figure something out in just a moment. This next one, again, is just one you need to memorize. It doesn't come up quite as frequently as this one, but it does come up. And so this time, again, the limit is going to, as x approaches 0, of this cosine x minus 1 over x. But this time the answer is 0. And then the last one that I would like you to memorize is this limit as x approaches infinity. So again, pay attention because those things change. Of this equals e. Now, this should remind you of the compounding when you learned about the money that was compounded weekly and monthly and semi-annually and things like that when you were studying exponentials and logarithms in previous math classes. That's what this little parenthesis reminds me of. And if you remember, if you compounded continuously, it became an e. And so that's how I remember this one, is by recognizing the compounding similarities there. Okay, let's move on to some examples. Okay, our first example is limit as x approaches 2 of 7, and so this is the horizontal line example, and so your answer should just be 7. Number 2, the limit as x approaches pi of tangent x. Not everything that you're going to see is one of those famous limits. Some are just trig. So again, you're going to go with the algebraic steps. You're going to plug in. So I'm going to plug in what is the tangent of pi, and that's where knowing your unit circle comes in. And so pi is over here. The point is -1, 0. Tangent is sine over cosine, so 0 over -1. And that's 0. So the answer to that limit is 0. We're going to figure out number 3 the same way. Again, we plug in, because that's always our first step with algebraic limits. So sine of pi over 4. And pi over 4 on our unit circle is right here. And the point is square root 2 over 2, square root 2 over 2. So the sign is square root 2 over 2. And that's the answer to our limit. Okay, the next 4 examples are going to be versions of that sine famous limit example because, like I said, it's pretty common that they're going to ask about that. And so number 4, I have 5x with the sign and 5x on the bottom. And as I said, anytime those match and your limit is going to, as x approaches 0, then that answer is going to be 1. But if you look at number 5, we have a 2x here, but not here. And so those don't match perfectly. And so you have to do a little bit of manipulation to get to something that looks like the famous limit. The way that you can do that is by multiplying by 2 over 2. Why can I do that? Well, what is 2 over 2? It's 1, and anytime I multiply something by 1, I'm not changing its value. However, what this does allow me to do is to get a 2x on the bottom. So I'm looking at it like the limit as x approaches 0 of a 2x on the bottom, a sine 2x on the top. Now, what do I do with this 2? I'm going to put it over here beside of it. Okay, now these match, and the limit of this part is 1. But I still have that 2, so I bring that 2 down, and 1 times 2 is 2. So the answer to my problem is 2. Alright, example 6. This is kind of the opposite situation. This time I have a plain x with the sign and a 3x on the bottom. I can't multiply like I did in number 5 and put something with a sign, because this is a stronger bond than multiplication. You can't just stick something in it. So I have to make this be sine x over x. The way to do that is to look at it as if it was 1/3 times the sine x over x. It's just kind of separating that out because it was just a number. I mean, we multiplied this number in, we can take that number out. So I have 1/3 times that. And again, you can look at these two limits separately and just multiply their answers together. So this 1/3 is still 1/3 because it's your first famous limit. And then the sine x over x, the limit is 1. And so 1/3 times 1 is 1/3. Okay, next one. This is where it gets a little crazy. In this one, I have sine on top of sine and 5x over 3x. You can't just reduce. It doesn't work that way. So what you can do is separate those two things and think about, okay, 5x has to be on the top of a fraction, and the sine of the 3x has to be on the bottom. I need this to be the sine of 5x over 5x, and this to be the 3x over the sine of 3x, so that it will meet my rule. So to get a 5 down here, I have to multiply by 5 over 5. I can't just multiply by a 5 on the bottom. It's not legal. I have to multiply by 1, and 5 over 5 is 1, because I can't change the value of this. I also need a 3 on top, so I'm going to have to multiply by 3 over 3 to fix this one. And then finally, I didn't have x's in either place, so I need to multiply by x over x to be able to get x's where I need them to be. So I haven't changed the value of the problem because I've multiplied by 1 times 1 times 1, and that does not change the value. What I can do is put things where I need them to be, because multiplication is commutative, meaning I can move it around, change the order. So I'm going to take this 5 and this x and stick them under the first one. And then I'm going to take this 3 and this x and stick them on top of the next one. And I'm left with a 5 and a 3 that I have not moved. So now I can look at the limits separately. The limit of this, because they match now, is 1. The limit of this, because they match, is 1. And then the limit of 5/3 is 5/3. So 1 times 1 times 5/3 is 5/3. Now I want you to look at the last 3 examples. Here we had the limit as x approaches 0 of sine 2x over x, and our answer ended up to be 2. In number 6, we had the limit as x approaches 0 of sine x over 3x, and the limit ended up to be 1/3. So here the 2 was on top, we ended up with 2. Here the 3 was on the bottom, we ended up with 1/3. And then in number 7, if you look, you had a 5x on top of a 3x, and we ended up with 5/3. So you could shortcut these problems if you can just glance at it and see the pattern. And so they expect you to be able to do that, but this is the math behind it. You need to still understand where it comes from. So again, you can shortcut, but know where it all comes from. And that concludes this lesson.